Hey everybody, it's Mr. Chris again at the Hudson Area Public Library in the summer of Take and Make Kits. So this is another in our series of kits that were prepared for our virtual summer camp program. I had leftover materials and I've turned those into Take and Make kits to use up all the supplies we had. So this week's activity is air pressure. So if you have the bag, you'll notice some things sticking out of there in the kit. So what I'm going to do is, if I can share my screen here, I'll do a couple of slides that explain the science to your kit and then what's in your kit bag and how to optimize and use that and have some fun. So let me see if this will share. And there it is. Okay. So this one for changing air pressure, again, my name is either Mr. Chris or Mr. Mick or Space Guy, as some people call me. And this kit's a lot of fun because you'll get to use a styrofoam glider that's in the kit and have some experiments with air pressure. So what are we talking about? We're talking about air pressure. Air pressure is all around us right now. No matter where you are watching this, you're feeling 14.7 pounds per square inch of air pressure. So that's all the atmosphere. If you go outside and look up, all the air and atmosphere that is around us on the earth, that's like the weight of all the air pressure equals at sea level, which we're all at here in Hudson, is about 14.7 pounds per square inch. So you don't feel it, but that's that pressure. That's what allows us to have liquid in a liquid state, like rivers and lakes. We're right by the St. Croix River, and you may, when you've done any traveling this summer, driven by several lakes in the area, Wisconsin and Minnesota. So that's what allows liquid to stay in liquid form. If we had less air pressure, like on Mars, for example, if we were all on Mars, the atmosphere is about a hundredth of what it is here on Earth. And that's why there's no liquid on the surface. There's ice underneath the ground, and there's ice at the North and South Pole, but there's not any lakes or oceans anymore on Mars because there's not enough air pressure to keep it in liquid form. So this is an example, like a 3D weather map. So maybe if you watch the news with your parents, or you've seen weather alerts when you're watching TV, a storm might be coming, you'll kind of get that overhead view and it might show the storm coming. This is kind of a 3D sideways view. So it's showing you the temperatures and then how low pressure and high pressure kind of interact or relate with each other. So high pressure is always going to want to go to where there's less pressure. So that's how weather people know when there's a storm coming. And if you see like a hurricane and it's heading for Florida, how they can do models of where it's going to go, because they know that the hurricane has a lot of high pressure with it, and it's going to find the area of least resistance where the lowest pressure is. So that's showing the track of like this storm coming in. So you see the ocean over here, and then it's going toward land, and the storm's generating high pressure, and it's moving to that low pressure direction. And then when the storm kind of dumps all that rain and moisture that's accumulated, it's going to go back to evaporating. All the heat will come out, and that'll drive that cycle. That's why you see the arrows, because as that evaporation happens, it'll drift towards a higher pressure area, and the cycle begins again. So water vapor, again, is another thing that's all around us, kind of like air pressure, but you don't see it. It's invisible. But we're really lucky that we live by the St. Croix River. And so by the river, there's all the water in the river flowing. And on a hot summer day like we've had, some of that liquid will be turning into water vapor. So the sun comes out, it's heating up the water, and when it gets to a certain temperature, it'll cease being a liquid and it'll turn into what we call water vapor. So you don't see water vapor. It's rising through the sky with the heat of the day. When enough water vapor gets together, we can see it. That's when it takes the form of a cloud. So when you see those white puffy clouds, that's a whole lot of water vapor that's gotten together to form that cloud. And then, as some of you know, depending on the weather conditions, if that turns to a gray cloud, a dark cloud, that means that it's going to rain. So all that accumulated moisture it has is kind of pouring out of the cloud in the form of rain. So again, reiterate what we have here on Earth at the surface. At sea level is about 14.7 pounds per square inch. The pressure gets lower the higher you go. So if you know crazy high places, like maybe you've heard of things like Mount Everest, really high mountain, sometimes climbers need oxygen because there's so little air pressure and atmosphere. The higher up you go, that you need to bring your own oxygen to go climbing. So that 14.7, that number will get smaller and smaller the higher and higher you climb, or the higher and higher you fly in an airplane. So this is an example of that. It's really tall mountain peaks. Maybe you've gone on a trip or to a national park or things where you've seen really high mountains, and you can look at them kind of like this photo where you're on the ground looking up at the mountains. So you know the pressure you're having, 14.7 at sea level, is going to be much less if you were to climb all the way up to the top of that peak. And this is an example of what I was saying. So these are hikers on that mountain we just looked at, and they're wearing the protective gear like sunglasses and insulated layers to keep them warm because it's very cold up there. It gets colder the higher you go as well. And then an oxygen mask for breathing air because there's such little oxygen up there. It can be hard when you're huffing and puffing and climbing and exerting yourself to get enough oxygen to keep going. So airplanes fly at a pretty high altitude. If you've been lucky enough to be on a commercial airliner, you've taken a trip for summer or for the holidays, you're flying usually in the 30, 35,000 feet range is what most commercial airliners operate. So this is a special plane. This is a research plane that NASA operates called an ER-2. And you can see the NASA logo on the tail there. And this plane has really long, flat wings that allow it to kind of soar at very high altitudes without using a lot of fuel. And so this ER-2 can get up to 90,000 feet to do experiments and to map the Earth and several interesting things like that. So this flies about 3 times higher than any of us have flown in a commercial airliner. And so they actually have to wear spacesuits up at that height because where we don't need to wear special gear on an airplane, it's pressurized and we can be comfortable in shirt sleeves and it's temperature controlled and they're piping the air in for us to breathe. If you keep going higher, it actually becomes dangerous if there was a depressurization or a crack in the cockpit or they lost pressure in the airplane. You wouldn't survive it. So they have to wear a spacesuit. And so this is these special suits. And then you can see here, they're putting the helmet on. You have the glove rings, and that's that NASA ER-2 behind the pilot here. And so it's almost like going to space. You're very, very close. There's very, very little atmosphere up there. So that's why they have to wear what looks like an astronaut suit for going to the moon or going to the space station. They're not going that far, but there's such little atmosphere up there, you almost need to dress the same. And this is a view from that ER-2. So this is where you're seeing the black of space. You can see the layers of the atmosphere. And it's a lot higher if you've been lucky enough to have a window seat on an airplane. This is a lot higher than anything we see looking out the window on an airplane. So this is really, really getting up there. And then again, that Mars example I gave earlier, we've got a unique helicopter on Mars right now that some people are like, well, how can a helicopter work on Mars if the atmosphere is so thin, 100 times thinner than Earth? Well, the engineers took that challenge up when it was decided that we would send an experimental helicopter, see if we could make this work. And so they did a lot of research, they did a lot of experiments, and they found a design that helped make it work. So one was to keep the weight as low as possible. So this entire helicopter, this is an artist's depiction of what it looks like on Mars, but this is exactly what the real helicopter looks like. It weighs 4 pounds, the entire helicopter. So that is not that much. So if you have ever gone to the grocery store, this is the weight of a few good size apples or a small bunch of bananas is the weight of the entire helicopter. It has a little rectangular solar panel at the top to charge between flights, to charge the batteries. It has a small battery on board. And it has these 2 really long, thin, strong carbon fiber counter-rotating blades. So counter-rotating means each one rotates in an opposite direction. And that's to help keep it stable. If they're both rotating in the same direction, it could pull it one way and make it less stable. So if they're counter-rotating, That's another way to make it very stable. And then the carbon fiber, you may have had experience from someone in your family if they play tennis. Tennis rackets, nice tennis rackets at the store are made out of carbon fiber. It's a very lightweight, very strong material, almost impossible to break. And so that's why it's very popular for tennis rackets, because it's very light and it's almost impossible to break. And it's a good thing in a tennis racket. So the blades are much longer and thinner than they would be on Earth. And this carbon fiber material helps the helicopter push against that thinner atmosphere. And then it has two cameras, a color camera and a black and white navigation camera in the bottom to kind of map the terrain and know where it's going. And then you see the 4 landing legs there. And then it has a little data transmitter. It can, after it lands, it can transmit its data to the rover that it hitched a ride to Mars on. There's the Perseverance rover, and this is the Ingenuity helicopter. So every time Ingenuity lands, it can beam its photos and data back to the rover, and then the rover in turn can send all the data back to Earth. So this has worked. It was an experiment. There's been 10 flights so far for the helicopter. It's still working as of this recording on Mars. They have future flights planned for it. So your experiments in your bag. If you want to grab your bag, I will stop sharing here. And then we'll look at what you got. So that's kind of what your bag looks like. There's red and blue planes. So you'll have this in here. I'll just talk a little bit about putting this together so it works, so you don't snap anything and break it. So you're going to want to be using the wings. You're going to want to see that it's curling up on the edges. Curling up is the way you want, not curling down. If it's down, that's not going to work for you in your plane. So make sure you have it's curling up. And then you're going to want to note this little center notch. That's going to disappear. If you put the plane together properly, you're not going to see that anymore when you slide that in. So your cockpit is at the top. You got to see that slot, and you're going to tip the wing to allow you to get that curved piece in. You don't want to push it in straight and kind of bend that. You want to follow the curve that it has. Slide that in, and then you're going to go all the way until you get to, it gets harder when you get to that middle piece, because that's when it's going to get nice and snug so the wing doesn't fall out when you are flying it. But if you just work it back and forth a little bit, you should get to where that centerpiece is completely gone, because it's underneath the fuselage there. You got your beginning of your plane. Your other one is going to be your tail piece, and it has a sticker on the bottom. So that helps you out. So the sticker should be on the bottom, and you're going to put the tail piece in. So flat piece forward. And then you'll notice you got 2 notches on the back. So what we're going to start with is the flat one on the bottom, where it looks like it's in line with the front wings. Same thing. It's got that kind of notched centerpiece. So you know you're going to be sliding until you make that disappear. And there you go. Now we'll note when you want to do loops, this is when you're going to carefully take that piece out and do the exact same thing and put it in the higher angled slot. That's going to allow you to do loops, because the air pressure is going to be pushing down on that fin in the curve, and it's going to make it want to go up. If it's in this flat position, this is for distance, where it's in line with the main wings, and it's going to have stability, be able to fly like that. So blue ones and red ones, I think maybe one white one I have in the kits. So that's your plane. And then the other things require, and then there's a little sheet in there that shows you that. If you forget about my video, it'll show you how to make your inserting the wings and the adjustments in there for that. Then you'll find a little packet of papers. So you should grab that, and this is going to have a couple things for experiments to do. So you'll have one with little note cards, index cards that I put in there. One with 2 soda cans, empty soda cans that I put in there, and a straw. And then you'll have a bendy straw with a little cheese ball in there. So all those are in the bag. The cheese balls in a little plastic bag. We'll have empty soda cans. We'll have more straws. And your note cards in that. So read through this packet because this explains the science. I'm not going to do that all in the video here. This was just to show you what the materials are and that you'll have everything you need to do to run these experiments. So there's three main experiments you're going to do. It's going to be the plane, the cheese ball, trying to levitate that with your bendy straw, and then the cans. Fourth one is the index cards. So you're going to read through those. There's only the sheets for the experiments, not too much reading. And then your airplane, you're going to get to fly. So on the back of one of these pieces of paper, it'd be great if you could track your distance. What's your maximum distance that you can get with throwing the plane, if it's in your yard or at a park and whatnot. So usually you do 3 trials. You'll do your first test, your second test, and your third test. And then what's the longest distance you got out of your experiments? And then if you want to switch over to putting the tail in a higher slot, you can see how many loops you can do. What's the most loops you can get out of one throw doing that? So you can try doing that again wherever you're at. Or if you want to be getting a little bit of altitude, throwing it off from a chair or the porch or things like that, if that makes a difference in getting your loops. And then you're going to get the little explanation on the forces that are putting lift on your wing. So there's kind of 4 forces of flight we talk about. So real quickly, they are the thrust. So that's going to be, since there's not an engine on board, how hard you're throwing it is going to be the thrust. So you want controlled thrust. You just don't want to close your eyes and fling it as hard as you can because it might go right into the wall or into a tree. It's controlled thrust. So you're holding it properly by the wings. You're not holding it at the nose. You're not holding it way back here. You want to get a good balance point so it's in level flight. And then you're trying to throw it level with the ground and see what kind of distance you can get. If it's a little breezy or windy, you want to try to throw into the wind if you can. And that'll help you control the plane a little bit better for that. If there's a crosswind, it's going to take your plane a little bit more in that direction in doing that. So thrust is one of the forces of flight. What level of thrust do you have? Another one is lift. You're getting lift from the wings. And that's in that diagram there that you can read about a little bit. Because the wind, the air is moving faster over the top of the wing, creating lower pressure. We talked about high pressure and low pressure. So that lower pressure is going to make the plane lift because it is creating that pressure difference in the plane. So you have lift, and then you have another force, gravity. Gravity is pulling down on us all the time here on Earth. That's why we stay stuck to the ground unless you're jumping up and down. But that's the same applies to airplanes too. So you have gravity is always pulling on the plane. So that's counteracted by the aerodynamics to the plane and how much thrust you have to the plane for doing that. And then another force you have is drag. Depending on the design of the plane, there's always going to be air pushing against the plane. So you want to try to have an aerodynamic shape that allows it to flow smoothly. So you see how there's this nice aerodynamic shape, everything's smooth and curved. But there's going to be air hitting points like the front nose that we can't get around that. No matter how smooth we make it, there's going to be air hitting there, air hitting the front tips of the wings, air hitting the tail. So that's going to cause an amount of drag. So the different designs of planes have different amounts of drag, but that's another force for flying. So I hope you have fun with these experiments. Would love to see any photos if you want to send in from doing that. The other one you can do when you have the cheese puff that you're doing is how long can you get that to levitate? Because you supplying the air pressure blowing in the straw, if you properly have the cheese ball centered, it will stay on that column of air. And that's due to high pressure and low pressure. Again, the air force you're pushing around the cheese ball, it's creating that kind of column of pressure where it's holding the cheese ball there. We're not seeing the high and the low pressure, but we know it's happening because that's what's keeping the cheese ball there versus just flying off when you blow it. So different experiments in your kit, pretty self-explanatory with the sheets that are in there. And again, we'd love to see any photos of you doing your experiments and how it went, tracking your results. And we'll have more of these camp kits coming out for the last few weeks of the summer here. I hope you enjoy those as well. Thanks a lot. We'll see you soon.